Hello, this is a video on resultant and equilibrant forces. So what is the meaning of resultant force? So if you have a system of forces, that is, you have more than one forces acting together, the resultant is a force, is just one force that will have the same effect as all the forces acting together. Okay, so the resultant is basically a single or a force that has the same effect as two or more forces acting together. So what does this mean? So if you have two forces, let's say you have a force, let's say you have an object here, you have a force that pulls the object in this direction, let's say, and that force is Fa, and you have another force that pulls the object towards this direction, Fb. So the force that this object will feel is basically the resultant overall. For example, someone is pulling you to the left, and another person is pulling you to the right. The resultant force on you is the force that you're going to feel is basically the resultant of these forces. So how do I get the resultant? Well, this is a system of collinear forces. They act through through a point, but they are on a straight line. So the resultant of that force, of these forces you see here, is basically Fa minus Fb. So if you do Fa minus Fb, so what I've done is that I've chosen this. If Fa is bigger than Fb, then it means that the resultant will be towards this direction. Okay, it is going to be positive. That means I've chosen the right direction. Okay, but if Fb is bigger, that means I'm going to get a negative direction. So that means it's going to be towards the direction. So let's say this is, let's say the Fb is 5 newtons and Fa is 3 newtons. So the force that this object will feel, Fr, will be, this time around, I know that, okay, Fb is bigger. So it's going to be Fb minus Fa. So which is 5 minus 3 is 2 newtons. So it means that it's going to feel the force of 2 newtons that tend to move it towards the right, because the direction of the resultant will be the direction of the bigger force. So the object will move towards the right, okay, in this time. So if Fa was greater, then the object will move towards the left. Take note of that. Fa less than Fb, it means that it moves to the left. And if Fa is greater than Fb, the object moves to the right. Okay. So, but this for collinear forces. What if you have two forces acting at right angle to each other, for example? So you have two forces acting like that at right angle to each other. Then the resultant, what do you think the resultant will be? It's going to be a force that acts that way. Okay. So I can move this force. Let's say this is F1 and this is F2. I can move this force here to this point, because if I do that, I've not changed anything, because the direction is the same as at right angle. It's still at right angle here. So I've not changed the direction and I've not changed the magnitude. So the force will be the same. So if F1 is here, then I form a right angle triangle, and the resultant will be the hypotenuse. So if I apply Pythagoras theorem there, I can find the resultant of the forces. So R will be square root of F1 squared plus F2 squared. So that's the magnitude of the resultant. So how do I get the direction? So I can get the direction. So let's say I consider an angle the resultant makes to this F2 force. So the tangent of that angle will be F1 over F2. So it means that the direction, as the angle it makes to F2, will be tan inverse of F1 over F2. Okay, so that's when you have two forces acting at right angle to each other, which means, let's say you have an object here, and one force pulls it towards this direction, and another force pulls it towards the direction at right angle, acting through this point, this object will move in the direction of the resultant. So this object will move in the direction of the resultant. It will not move in this direction, neither in this direction, but in this direction at this angle theta that you calculate using this formula. Okay. That's for two forces acting at right angle. So what if the forces are not acting at right angle? Okay. So let's say you have one force that acts like that, let's say F1, and you have another force that acts like this, F2 at an angle theta. Okay. If I want to get the resultant, I can apply the law of triangular forces. So I can move this force. If I move this force, I draw a line that is parallel to this, and I put it head to head. So I move it from here. The tail of this, I put it on the head of this. That is tail to head. Sorry. So now this F1, I move in here. So it's going to have the same effect because I've not changed anything. That's still going to be theta. You know that, okay? Because they are alternate. I'm sorry, they are corresponding. So now I've moved this force here. So the resultant basically will be this force here, R. So the force that completes that triangle. So it is the force that it is the line that you draw from the starting point of this one to the finishing point here. So that means I have a triangle that looks like this. Then I can apply, so I can determine this angle here. This angle will be 180 minus theta, right? So if this is a horizontal force, I can then use cosine rule to obtain the 1 theta. This is F1, this is F2, and this is R to obtain the resultant. So because I know I'm looking for the side that is fitting the included angle. So if I apply cosine rule, so R squared will be F1 squared plus F2 squared minus 2 F1 F2 cos 180 minus theta. So cos 180 minus theta will be equal to minus cos theta, because in the second quadrant, cosine is negative. Okay, so in the second quadrant, cosine is negative, but the angle here is basically 180 minus theta. So which means if I do then R squared can be written as F1 squared plus F2 squared plus 2F1 F2 cos theta. Okay, so that's how you obtain the resultant. So what is equilibrant? Equilibrant is a force that has the same magnitude as the resultant. A force that has the same magnitude as a resultant, but acts in opposite direction to it. In opposite direction to it. So which means if I have two forces acting on an object, let's say you have a force acting in that direction and you have another force acting in that direction. So we've established that the resultant is at right angle. So the resultant will be like that. So the equilibrant basically will be a force that has the same magnitude. Let me use a different color for that. It will be a force that has the same magnitude as R, but acts in opposite direction to it. So you can see it acts in opposite direction. So I call that the equilibrant E. Okay, so E is equal to R in magnitude. Don't forget that. So if you are to define equilibrant, it's basically the force. This force can also be defined as a force. Color. It is a force that must be added to a system of forces to keep the system in equilibrium. To keep the system in equilibrium, a state of equilibrium. And you can see that clearly, because if the resultant tends to move the object in this direction, let's say the resultant has a magnitude of 5 Newton and is pointing like that. So if I apply another force that is also of magnitude 5 Newton, but in opposite direction, you will see that this object will not move. So, and what you want to maintain a state of static equilibrium, you don't want that object to move. You want it to remain stationary. So which means you need to apply a force that has the same magnitude as the resultant, as the force which tends to move it in a particular direction. You apply that same force. We applied a force that has the same magnitude, but opposite direction to it. Okay. So that's it for this video, and I'll see you in the next.